Let's take a look at this example. It looks kind of complex, but for us, this is not the problem. We have circuit with two current sources, right? Some students get afraid of these two current sources. But let me show you that this problem is not very complex, okay? So what I'm supposed to do first? I would redraw this circuit a little bit in order to make it looking a little bit simpler. Please notice that this current source is in parallel with the branch where we have capacitor and resistor R2. So I'm going to just change the positions of the current source and this branch. So I'm going to have current source, I have inductor, I have another current source, this is going to be my IS2, and I have resistor R1, and I have capacitor C, I have resistor R2, and I have inductor L2, I have resistor R3 and resistor R4. Of course, this is inductor L1. Okay, so in my opinion, this circuit looks a little bit simpler. Why? Because we prefer to keep current sources and voltage sources on the left side. So maybe this is going to help you a little bit to understand the first steps which we're supposed to do in order to solve this problem. Please notice that current IS2, right, in equation has cosine. We're supposed to change the cosine to sine and simply write I source 2 is equal 4 sine, and I have 15,000 t. Because I convert cosine to sine, I'm supposed to add 90 degrees to negative 35 degrees. This is equal 55 degrees milliamps. Okay, so this is the step which we're supposed to do. Next, we're supposed to find the impedance of each inductor and impedance of the capacitor. So I have to find first ZL1, which is equal, remember this is omega L1. We have 15,000 radians per second times L1, which is equal 8.2 millihenries. And this is equal 123 ohms, an angle of 90 degrees. Please keep in mind that impedance of the inductor goes always with 90 degrees. Next, we're supposed to find ZL2. ZL2 is omega times L2, which is equal 15,000 radians per second times the impedance L2, which is equal 32 millihenries. So I have ZL2 equals 480 ohms, an angle of 90 degrees. And next we're supposed to find ZC, which is equal 1 over omega C, which is equal 1 divided by 15,000 radians per second times capacitance, which is equal 220 nanofarads. Okay, this is equal 303.9 0.03 ohms and angle of negative 90 degrees. Okay, so I found the impedances of inductors and capacitor. Next, what I'm going to do, I'm going to find Z1. Okay, I'm going to combine these two components together, and I'm going to call the total impedance of these two Z1, and total impedance of these three I'm going to call Z2. Okay, so I have Z1 is equal R2 plus Z sub C, where R2 is equal 390 ohms plus Z sub C, which is equal 303.03 ohms and angle of negative 90 degrees. This is equal 493.89 ohms and angle of negative 37.84 degrees. Okay, so this is the impedance of these two components combined together. Okay, they are in series, that's why I add them up. Next, I'm going to find the total impedance of these three components. Okay, so I have Z2 equals, and I have R3 plus R4 plus ZL2, which is equal 210 ohms plus R4, which is equal 190 ohms plus ZL2, which is equal 480 ohms and angle of 90 degrees. This is equal 624.82 ohms and angle of 50.19 degrees. So this is the total impedance of these three components together. Next, we can redraw the circuit, and we have current sources, and we have L1, this is my R1, I have another current source, this is I source 1, this is I source 2, and I have Z1, and I have impedance Z2. Okay, so we have to find the current which goes through resistor R1. You're supposed to realize that in this branch, okay, this one, we have resistor R1. Okay, so in this branch we have current IS1. So I'm supposed to say that I R1 is equal I source 1, which is equal 22 milliamps and angle of 47 degrees. 22 milliamps and angle of 47 degrees. So this is my current IR1. Next, we're supposed to find the current which goes through resistor R2. I'm supposed to find IR2. Okay, so please keep in mind, we redrew the circuit, and this is my resistor R2. So R2 is the part of the impedance Z1. So what I'm going to do first, please notice that we can solve this problem in this way. we have current. I'm going to call this I, Z, 1, 2. It means that this current will go through the impedance Z1 and Z2. In order to find Z12, I'm going to use the product over the sum. So I have Z12 is equal Z1 times Z2 over Z1 plus Z2, where Z1 is equal 493.89 ohms, an angle of negative 37.84 degrees, times Z2, which is equal 624.82 ohms, an angle of 50.19 degrees, over, we have 493.89 ohms, angle of negative 37.84 degrees, plus 624.82 ohms, an angle of 50.19 degrees. This is equal 381.14 ohms and angle of negative 0.276 degrees. Okay, so this is the total impedance of these two impedances. So we found the impedance Z12, and next we're supposed to find the current IZ12. As we said before, this is the sum of these two currents. Why? Because these two currents are going to the same node. Okay, so IZ12 is equal I source 1 plus I source 2, where I source 1 is 22 milliamps, an angle of 47 degrees, plus I source 2 is equal 40 milliamps, an angle of 55 degrees. So IZ12 is equal 61.86 milliamps, an angle of 52.16 degrees. So this is the current which will go to this point, okay? And at this point is going to split into the current which will go through impedance Z1 and current which will go through the impedance Z2. So what we are going to do right now, we are going to simply find the current IZ1 and IZ2. So if you want to find IZ1, and we of course are going to use the current division law, we are going to simply write IZ12 times total impedance of these two impedances, I mean impedance 1 and 2, so I have Z12 over Z1. This is equal, IZ12 we found is equal 61.86 milliamps, an angle of 52.16 degrees, times Z12 is equal 381.14 ohms, an angle of negative 1.276 degrees over Z1, which is equal 493.89 ohms, and angle of negative 37.84 degrees. So IZ1 is equal 47.72 milliamps and angle of 89.72 degrees. This is the current which will go through impedance Z1. But please keep in mind that the impedance Z1 contains capacitor and resistor R2. So you're supposed to realize that this current, which we just found is equal to current which goes through the capacitor, and this is the same current which will go through the resistor R2, so IR2. Okay, so we can say that we found the current IR2. Next, we're supposed to find the current which will go through impedance L2. Okay, so how we can do it? We can simply perform the subtraction. We can use KCL. Okay, and if you want to find IZ2, right, you can subtract from IZ1 to IZ1, which is equal. IZ12 we found is equal 61.86 milliamps and angle of 52.16 degrees minus IZ1, which is equal 47.72 milliamps, an angle of 89.72 degrees. Okay, what I did? We found this current and we found this one. So if you are going to subtract, because this current is going to split into two currents. So if you are going to subtract from this current, you will get this one. So this is KCL. You're supposed to obtain the value of, let me write this down over here, 37.73 milliamps and angle of 1.72 degrees. So we found the current IZ2, and this is the current which will go through inductor L2, resistor R3, and resistor R4. So we found IL2. Next, we're supposed to find VXY, voltage between these 2 points. So this is the voltage across impedance Z1, because this is nothing else, just my impedance Z1. So in order to find VXY, I'm supposed to find VZ1. I'm going to use Ohm's law this time and simply multiply IZ1 by Z1. Current times impedance gives me voltage, where IZ1 is equal 47.72 milliamps and angle of 89.72 degrees times Z1, which is equal 493.89 ohms and angle of negative 37.84 degrees. Okay, multiply these two numbers together and you're supposed to get the value of 23.57 volts and angle of 51.88 degrees. So this is the voltage between these 2 points. Next, we're supposed to find voltage across the capacitor. How we can find that? Please realize that capacitor is part of Z1. Okay? So if I'm going to multiply current IZ1, which is equal to IC, by impedance of capacitor Z1, this is going to give me the voltage VC. So IZ1 is equal 47.72 milliamps and angle of 89.72 degrees times ZC, which is equal 303.03 ohms and angle of negative 90 degrees. This is equal 14.46 volts and angle of negative 0.28 degrees. This is the voltage across the capacitor. If you want to find voltage across inductor L1, you're supposed to simply multiply the current IS1 by the impedance of this inductor. VL1 is equal I source 1. Let me remind you one more time. This current source is in series with this inductor, so the same current, IS1, will go through this inductor. So if you want to find voltage across that inductor, you're supposed to simply use IS1 times ZL1, where I source 1 is equal 22 milliamps and angle of 47 degrees times ZL1, which is equal 123 ohms and angle of 90 degrees equals, so VL1 is equal 2.7 volts and angle of 137 degrees. We found all currents and voltages, so we can say that the problem is solved.